Hi everyone, I'm Saar again. Going to do another soldering session, and let me just check that everything is sort of streaming. Okay, I got a signal that everything's fine. Just make sure I have the chat without seeing myself. Right, so today we're going to build somebody else's project called NoiseX from MADLAB. And MADLAB is James Hutchby, who designs the circuits, and I've always liked what he's ever since I became aware of his work. I liked how I like the aesthetic, the clever circuitry behind the project. Phenomenally good coding, squeezing performance out of microcontrollers, and I've got to experience that firsthand by collaborating on a previous Boldport Club project called Stringy, which is this thing. I'll change the camera view. This is Stringy, which is my re-implementation. It's not focusing again. Of the Funky Guitar project from MADLAB. So if you power it up, you play as a stylus. There's a small pick controller here. And you can change the tones. Very clever. So James sent me this project, which is called NoiseX, and I'm gonna build that, and it may or may not be a future Boldport Club project. So leave it at that. I wanted to show you the website. This is the website of MADLAB for this particular project. So if please have a visit, madlab.org /kits, and you'll get to all the different kits. Now, when I saw this picture at first, I thought it was going to be small. Then I got it in the mail, and it turns out to be quite larger. I mean, this kind of you see it on the screen. It's not, it's pretty big. I don't know. Oh, okay. So something changed for some reason. Now it should focus. Yeah, there we are. So it's a project, and here's a closer look at. Dun, 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 dun. Stringy. Okay. So I'm gonna build this NoiseX because I want to see how I want to hear how it sounds, and there is on MADLAB's website there is a wonderful audio file where you can listen to how it actually sounds, and that's what really captivated me about this project. It sounds really good. Hopefully, if there are no mistakes, we'll hear that later on. Okay, so let's start. Before I start, two things. I have this fan here with some filter And it's basically, I'm using it in reverse, so it'll suck the air out. If you're soldering, solder safely, and use the appropriate equipment. The other thing I'm going to do is I have an anti-static strap here, which I'm going to put on my leg. As long as it's touching you, it's fine. So it's just that way it doesn't bother me when I'm stretching my hand along the table here, and I won't get some surprises at the end due to anti-static, which, yeah, the last thing I want is this to be to not work because I zapped something. Alright, so I have seen the material that comes with the project, but I haven't done any real preparation for the assembly, so that's how James sent it to me. There's quite extensive instructions here, how to construct it, how to use it, the modes, you know, more comprehensive notes about the modes, and the bill of materials. So, I guess we'll start with constructing it. One interesting thing about the board that I noticed when I got it, I thought, oh, it's, that's not zooming in. It keeps going, something keeps changing. It's a single layer board. There's no copper on here, but there is copper on here. But then I noticed there's actually copper in these vias. Those go all the way. So it is a 2-layer board, but James decided not to put copper on where there's supposed to be components being soldered. And I thought about this, and the only reason I could think why this would be a good idea is so people don't confuse which side to put the components. You can't possibly put the component on here and then solder on this side because there's no pad. But James can correct me if I'm wrong on this. And but you don't get that that fill with copper, so the connection might not be as good as it could be. But on the other hand, the rings, the copper rings, exposed copper is quite large, so there shouldn't be an issue with this kind of board. Okay. So let's see. First fit and solder the resistors R1 to R12 and trim their legs. Identify the resistor by the colored stripe on the body. Right, but what so these are the resistors, but I don't have a reference. Okay, so I might be missing a schematic because I don't actually have, unless it says so. No. So how do I know? How do I know which is which? think there must be a missing. Oh, right. Okay. No. So that's the component list is here, right? So R1 is right. So I'll bring up here for my reference the resistor values, because I might get it wrong, being on video and all that. Of course, I get to a site that doesn't let you go straight in. Okay, that'll do. Okay, so 47. We're looking for 4, which is yellow, and 7, which is purple, so it's this one. And that's R1. Sorry. Okay. R1. So the way I normally do this, just put it in there, tighten it up, and then bend the wires like that, so it stays in place. Okay. R2 is 100, so we're looking for black and black and brown. Oh, sorry, no. Brown and black. Brown, black, brown, right? Because it's 10 to the 10 to the power of 1. So, sorry, brown, black. Yeah, so, yeah. So this is 10 R, and this is 100. So, all right, good. R2. This is R11 is 10, so we'll just sort that out. Where are you? R11. R11, here you are. Okay. And we have 2 more that are, I think we have 220, which is red times 10 to the 0. Sorry, 10 to the 1, so times 10. So 220, right? This is R10. R10 is here. And then the last one, that is, these are 9, 470, so yeah, we have 47, and so yellow, purple, brown, so 47 times 10 to the 10 to the 1, it's 470, and that's our 9. Oop, yeah, that's stringy going to sleep. James thought about everything and designed this. Okay, 1K, that would be R3, no, so 10K is R7, R8, R12. So R7. No. Here, R7. R8. Just checking that those two have the same bands just for aesthetic reasons. And R12. R12, where are you? Yeah, so here. Okay, and then the 1K, the rest, but we'll go through them. R3, R4, R5, R6. Oh, they're all here. Okay, R3. R4. R5. R6. Now, you know, it would be tempting to say, well, why didn't James put the resistor values on the board, right? Because then I wouldn't have to be looking at the instructions all the time. But that wouldn't be very practical, because when you normally make a kit, you send out the boards, you don't necessarily know what are the final values, and you want to be able to make changes later on after you receive the boards. Some tweaks here and there. If you have the values on the board, then that could cause more confusion than clarity. So completely agree with this decision to do away with that and create supplementary material. Supplementary material, of course, you can change. Silk screen on the board, you cannot, unless you respin the board, which will be a fairly silly reason to spin a board for silk screen. So slightly different style of soldering when the holes aren't plated, because there's no flow of solder into the hole like there would be normally. I need to increase the temperature here. Yeah. Not used to this. Kind of have to help it a little bit, The only thing it's going to attach to is that ring around the hole. Okay. I'm going to trim these now, and when you're trimming them, always hold what you're trimming so it doesn't jump out at you. I'm going to do the beautiful solder domes, but maybe at the end, because this is a flat board as opposed to the cordwood that I did yesterday, where I wouldn't have had access, so I did it as I went along. Here shouldn't be any problem. Yep, I just damaged the board here. That is not good. I might have to fix that. Okay, I should just be gentler with this. It's not meant for that. Okay, maybe I'll fix it now. So basically what I've done, I've lifted the pad with my cut out, so I just have to be a bit more careful. Because these things, because the holes aren't plated, are more sensitive. Okay, I'm gonna have to do some surgery already. Let me show you. Right here. Oh, I actually have the microscope on. Yeah, so this pad I lifted, you can see the leg poking through, and this is what it was connected to. So what I'm going to do is I'm going to scratch this off and solder the pin onto what I scratched off here. So just removing the solder mask. So, yeah. Okay, now I'm gonna put a little solder blob here. See if I didn't clip it so I put some solder on another area. This is not going well. So I'm using a wick to wick out excess solder that went from a ball that was on the iron onto holes that I haven't soldered yet. Yeah, that's not quite gonna work. Okay, I think I know what I'm gonna do. Of course, I have more 1K resistors in the lab, but I'll try to do this a slightly different way. Just pushing that pin as far as I can. Trying to somehow make a connection there. Not sure it's gonna work. Nope, kind of messed this up. Don't have flux with me either. Okay, try one more thing. Okay. Now, I'll do a continuity test. Basically, I want to see if this leg... Nope. Nope, it's not working. I can take a wire from here all the way around, or let's see, it's going to here. Yeah, but yeah, because there's no pads on the other side. see. You know, I'm just going to do this. Just going to use this wire. Yeah, so I even managed to do the wrong. Okay. Okay. So it turns out that I thought it was the wrong, it was a different resistor, so it might be something. Just going to push this through. Okay, try this again. Okay. Oops. Okay. So that worked. I think it's going here. Oh, around the middle one. No. Okay. This one is going to the middle one. Very strange. Very strange. I think this is quite a resistive track. That makes sense. I don't know what's going on. Well, clearly it's not set up for that threshold for beeping. The resistance for the threshold for it to beep is set too low. Alright, but there is a connection, so I'm happy with that for now. Okay. Okay, let's move on. I'll show you what I've done. So there was that resistor, a bit of the resistor lead coming out. I like just connected another wire to the exposed part of the of this track. Okay. So next, fit the chip sockets IC1, IC2, matching the notch in the socket against the notch in the symbol of the board. Care should be taken when soldering these components to avoid solder bridges between the pins. It is not recommended that chips are soldered directly onto the board. Yes, okay. Okay, so we have the chip and the socket. So it goes on that way, right? This is the notch. The notch matching the notch here. In this case, it doesn't matter. What matters is when you put the chip in, that it's correct. So the way I do this normally, well, in this case I just apply pressure. To make sure that it's flush. And do the diagonal opposite. And then just check. Okay. Right, so let's do the rest of them. It is indeed easy to make solder bridges here. Just be careful as you go. Also, there's sometimes pins that are right next to each other. In this case, these are vias. You don't want to short those as you solder. Okay, that's done. Now let's do this one. Right, IC2, IC1 is here. Again, just pay attention to the notch. It's nice when they match. Okay, again, do James follow the convention of pin number 1 being square, a square pad, which is what I use as well. Okay, this looks fine. Solder bridge. Just a little bit of a wire here. I would like to cut. Okay, so we have a solder bridge here. Like I said, normally if the holes are plated, there's a bit of a leeway because you have solder that will get sucked through the hole and onto the other side. So you have some flexibility here. That effect doesn't happen, but I think this is okay. Okay, so we've done that. Fit and solder the capacitors, paying attention to the polarity of the electrolytics. Negative is marked by a stripe on the side of the body. Okay. The tantalum capacitor C8 should be fitted such that the shorter leg is by the minus sign. Okay, so let's look at the capacitors. Okay, let's first do, well, the capacitors. Okay, so C5 is a square 1. Let's see what C5 is. C5 is 100 nanofarad polyester, which is normally this kind of package. It does have the value on it, but it has to be this thing. Okay, so now I check that it's flush. Okay, good enough. Cut these a little bit. Okay, what are the other ones that is just this one is the tantalum. Let's see, C8 is 10 nanofarad. Yep, 10 C8 10 microfarads. So 10 to the 6. Yes, that gives us 10 microfarads. That is C8. C8, where are you? Let's see, C8. Oh, C8. Okay, yeah. So there's the shorter leg to minus. That's what he said, right? That's what I would expect, but let's just be fair such that the shorter leg is in the minus sign. So shorter leg here. Okay. Okay, now let's do the ceramics. That's 100 nanofarads, 10 to the 10 to the 4. C4, C7, C9, C7, C4, C9, C9 is here. Okay, I know what I've done wrong with the resistors, not realizing this, not being used to soldering without a plated hole, is that I should have left the resistor legs not bended. So I shouldn't have bent them along the board, and then you get this nice nice solder joint on the lead. It just makes it easier to solder. So that's a lesson for whoever cares, or for me, the future. That's stringy, still alive. I'm actually not sure what it means, but I thought it means that it's going to sleep, or maybe it's just telling you that it's sleeping, waking up every now and then. But after this, I'll take the battery out. That's the multimeter. Okay, take the battery out. Okay, now we have 4 electrolytics. So C3 and C6 are 220, which is am I missing one? Oh dear, missing one. Did it fall on the ground, on the carpet? Yeah. Okay, I think it probably fell. I'm gonna look for it. Okay. Oh no. No, sorry. There should have been only 4. Got confused. Yes. Alright. Alright, so let's do this in order. 10 microfarads. 10 microfarads, C2. Where's C2? C2 is here. And the minus sign, you put the short leg. Now, yeah, I forgot what I was going to say, but that's okay. Alright, this is 220, and that is C3 or C6. C3, okay. No, that's LED 3. That's C6, okay. Put something underneath in order to get some, to get the board horizontal. Okay. Okay, another 220. That is going to be C3, and that's here. Okay. Again, these pins are quite close. I had a discussion with James about projects, and James wanted his projects to be quite accessible, so potentially chose bigger components. That is that the pitch isn't too close to. The legs aren't too close to each other. It's harder to sort of. Okay, so 100. That's C1. C1. Pull this up, basically heating both legs and pulling it up so it's flush with the board. Okay, right, what's next? Bend the legs of the regulator at right angles and solder it such that the metal heatsink is flat on the board and the side with the writing, is facing upwards. Okay. So this is the regulator, right? Right? Yeah. So basically saying bend this like that. Now bend it like this. And that basically prevents someone from soldering it the wrong way, right? So the text is facing upwards. Although there is no heat sinking effect here other than the package itself. But I imagine that it doesn't need a heat sink at all here in this case. Okay. Solder the LEDs, LED 1 to 4, matching the shorter leg also flat on the rim to the hole with the line. Matching the shorter leg, also the flat on the rim. So what it means is, this is somewhat oval. There's no flat bit on the rim. It's probably a variant of LEDs that he uses that doesn't have that. And these are quite oval. I've never seen those actually. You see? It's not strictly round. But what he's saying is sort of the LEDs matching the shorter leg to the hole with the line. So this is the hole with the line, shorter leg. Sometimes I hold it in place just through pressure with the iron and hold the other leg that isn't hot in place like that. So hold it with pressure. Okay, so the other side. Let's redo the other ones. Okay. Solder the push buttons S1 to S6. these don't have polarity. I mean, they do. There's the wider side, and that's obvious from the drawing on the board how it should go. Okay, I think I got an extra switch here, but okay, it's good. Okay. Solder the presets VR1 to VR4 and sliders. Okay. So, talking about these two and these four. The other side, of course. Writing instructions that for assembly is quite tricky for somebody who designed the board, and I bet this one is written with quite a lot of experience from James doing workshops and so on. To get it right, because the ordering matters in how easy it is to get the board. How, you know, if somebody's inexperienced, you want to give them the best experience possible, so they don't get put off by this. So it can't be too frustrating. Okay. Oh, yeah, these are huge. They're very satisfying. Is it really? There's a... Oh, okay. So it sort of floats like that. Large pads here. Okay. Let's get these things on. Alright. Okay, now the transistors. Transistors. 1, 2, 3, 4. What is this? Oh, something else. That's TR5. Huh. They're the same. Well, TR5 has to be this one, and these have to be these. Okay, 1, 2, 3, 4. It's a different package. Don't know if that's intentional to avoid confusion or some sort. Okay. So the audio jack. This is the audio jack here. and I'll sort of press fit it. Yeah, now it's in place. The pairs of holes are shorted anyway, so it's okay to have this sort of solder blobby looking thing. Sort of power socket. Getting anxious now. I want to see it working. My luck, something's gonna happen. Not luck, really. I was too quick with those pins earlier on, and that wasn't good. Okay. See? Okay, audio power. Optionally also fit the PP3 battery snap, which is this thing, which I am going to fit. Support holes are drilled onto the board for the battery. So these are the battery. So I'm going to put the minus. Means by support holes are these. So you put the hole, the wire through the larger hole, and then you bend it back, and that gives it sort of stress relief. Sounds like meditation, but it basically means that if you pull or tug on these wires, they're not going to tear off. It's a good idea. So we see just, yep, minus. Plus. I'm just going to leave it like that. And now you pull on it, and it's not going to. These don't get any of the stress. The solder joints are not going to get any of the stress. Okay. Okay. Red is positive, black is negative. Don't fit the chips into the sockets until you have thoroughly checked your construction. Check that all the components have been inserted correctly, and that there are no dry joints or no solder bridges between the pins. Then match the small notch in each chip. Okay. Touch the rubber feet. Either connect. Okay. The LEDs should flash twice if the board is functioning correctly. Alright. So that is done. I followed it through, and I think that it's okay. Now we're going to fit the chips in. Again, the important part is to get the orientation correctly. Now you have that notch here, and you have the notch on the board, on the chip. Just quickly show you. There's that notch, and also there's a little dot here that says that it's pin number 1. Indicate pin number 1. I see that these have been pushed in, which is normally something that you need to do for a fresh chip. But they just, I think James must have done that as a courtesy when he programmed them. Here, these have the angles, the angle of the leg. I need to bend them in a little bit. Have to be careful sometimes. You'll push them, and the pin will go. One of the pins will go underneath the package, and you won't necessarily notice. Okay, I'm not going to bother with the feet now. I have batteries here, and it came the kit came with this. Just will give us 6 volts, and it's connected through this 9-volt battery connection thingy. Alright, let's see if it's working. The LEDs should flash. Yeah, they're flashing. Okay. You see, it's flashing. Alright. Alright, now I'm going to connect it to the powered USB. Oh, yeah, I forgot to put these in, which are the knobs. Yep, there's one more knob. Okay. Alright, it's doing something. Various modes. Ah, this is so much fun. Okay, let me see the modes here. Okay, S1. I'm not sure what any of these do. Oh, S1 and S6 restart. Okay. Restart. Oh, there's toggle gain, save settings to memory. This is amazing. I mean, the kind of stuff that James does with the code in here is just remarkably good. So if I toggle gain, it's S3, S4. So high gain. Yeah, I'm not doing this justice for sure. Alright, wow, this is so good. This sounds great. The battery is almost done on the camera because I forgot to turn it. I forgot to turn it on. No, I forgot to change the battery before I started it, and it started out with me pulling out a pad. I'm not so used to this non-plated holes, which I keep mentioning, but I guess doing the beautiful domes on a board like that requires being very, very careful. I can say I'm not a fan of these non-plated holes, having gone through this, but the design and the board is is remarkable. If go to madlab.org, check out the other projects James has been doing, and it was just been a pleasure doing Stringy with him about a year ago. And like I said, we may or may not doing another project together in the future. If you haven't seen The Forbidden Planet, this is, I understood, an inspiration. I've seen it recently, again, possibly, may have seen it a long, long time ago. And you have these kind of sounds and the story behind the couple who composed the music for that. It's called electronic tonalities because they weren't part of the music union or music association or whatever, and they couldn't win an Oscar. It's the first movie score. It's a remarkable story. It's on Wikipedia, and yeah. So I think I'm gonna go rest now a little bit. It's much easier building boards that I designed. But I'm going to do more of this. I wanted to build other people's boards, and I thank James for sending me this wonderful thing. Thank you very much. Oh, yeah, plug Boldport Club. We're shipping on Monday. If you wanted to get the Cordwood Puzzle 3, which is this thing, go sign up, boldport.club. You'll get it. And some other wonderful things, and other wonderful things coming up in the future. Thank you. Have a good weekend. Bye-bye.